ViewPod by Apera AI. Bin picking productized. A complete, self-contained cell that ships vision-trained and robot pre-programmed. No integration project, no vision expertise required. Just connect, calibrate, and run in days, not months. ViewPod is built on Apera's 4D vision technology and expertise, battle-tested on production lines across North America and Europe. Stop planning, start picking.
Missed defects are costly. Musashi AI helps prevent them. Our Sentient software uses active eye, deep learning models to catch the defects traditional inspection misses, turning every scan into real-time insights. Our new production-ready modular platform is smaller, allowing for faster deployment at lower cost. Backed by our team at every step. Smarter inspections, superior results. Musashi AI.
The wait is over. Flexiv has just launched 2 brand new robots at Automate 2026, Enlight and Miko. From whole body sensitivity to advanced dual arm manipulation, this is what's next for automation. Head over to booth 2844 right now to catch the live demos.
Automation is evolving fast. Your design tools should too. With Onshape's cloud-native CAD and PDM platform, your entire team can work together in real time, from anywhere on any device. No installs, no downtime, no waiting. Just faster collaboration, faster iteration, and a smarter way to build products. For a closer look at the future of automation design, stop by booth 3778 and see Onshape in action.
Rital and ePlan are live at Automate 2026, demonstrating exactly how we're better together. Don't miss your chance to experience the power of software, hardware, and automation in one system. We're showcasing live demos and real-world success stories. Come see us at booth 2818.
Well, one of the things that really interested me the first time I came and visited you over there in the Akamai building in Boston was, and maybe this goes back to the decision to remove Boston Dynamics from the beginning of the name, is that the company is relatively, or maybe entirely, hardware agnostic, right? I mean, you were buying a lot of spot robots, but you've also been buying different humanoids to test out.
We have about 50 robots here. Some of them are arms mounted to the table, like an industrial arm, which we bought from Universal Robot. We have a couple of Unitree humanoids here, both the big one and the little one. We also have a lot of spot robots from Boston Dynamics. I think we have maybe 20 of them here. We have some Anybotics robots. We don't have a direct relationship with them other than being customer, but Marco Hutter, which is one of their founders, is the director of our Zurich office. And he's working, half time with us and half time with ETH, where he's been for a professor for a while. So yeah, we're hardware agnostic, and we build our own hardware. We have, a variety of hardware activities. You've probably seen the jumping bicycle, the parkour bicycle. We have arms and hands and torsos that we've been building, and we're building more stuff.
Yeah, you've been pretty open about this too, that, you were, I don't want to speak for you, but maybe to a certain extent you were hesitant to productize because you feel like productization can kind of, in a way, get in the way of innovation.
Hesitance too weak. We are not making any products. I think that we're really trying to work on the future, the next generation after the current generation. We want to make robots really smarter, more like easy to interact with, more like people. People know so much already that the task you're giving them is just kind of fits into the world that they know about. They have situational understanding, and that's really important, I think, for getting robots to be the next level beyond where they are now. Anybody who uses a robot today finds out pretty quickly what the limitations are, and that doesn't mean they're not useful, but it's a lot of work to make them do the things that they need, that you want them to do. So we're trying to, go past that. I think when you work on a product, there's lots of demands that you don't need to be working on if you're working on the future underlying technology, like the reliability of the robot. Boston Dynamics spends a lot of resources on making their, the Spot robot out in the thousands of hours of time between failures or between interventions. And, we want to concentrate on getting the new thing just starting to work.
Yeah, I suspect maybe one of the biggest hurdles there, and I'm curious, what your thoughts are as far as the Electric Atlas humanoid, but is pricing, right? I mean, Boston Dynamics has been able to build these incredible robots for decades now, but in terms of actually being able to sell a humanoid robot, you kind of have to rethink it from scratch.
Well, it's true. At the Institute, we're not worrying about how much the hardware costs to build.
Yeah.
That's another specialized skill requiring a whole system of supply chain and understanding what volume you're going to make the thing at. And we're not doing any of that. We're making prototypes that can be very expensive, and that lets you, explore more quickly than if you're trying to design a product.
What was that initial conversation with Hyundai like when you were trying to get this together? What was the pitch like? We're going to spend all this money and not make any products.
I wrote up a short document that they reviewed, and then we had a conversation. And I think they believe that investing in the future is an important thing for them to do. It wasn't a hard sell.
Yeah, it's interesting too. I mean, one of the things that I've noticed being more involved in robotics and the robotics community over the past several years is there's a sense of openness that you get in that world. As somebody who's covered like Apple for 20 years, there's a sense of openness, working with different institutes. Obviously, you mentioned ETH and you come from MIT, but there is a lot of sort of sharing of information and cross collaboration that happens.
Well, one of our goals here is to take advantage of that in both directions. I like to say that we're a halfway between a corporate lab and an academic lab. Academic labs are as open as you can find anywhere where, they want to share everything. Corporate labs usually don't want to share that much. And we're trying to be in the middle somewhere. So our people write papers, we open source some amount of work, and we're trying to take advantage of that community, help build the community. We're funding about a dozen university labs.
It does seem that way, and I will tell you that in my career I've been very blessed. Like I said, with great teammates and a great support system, and I was of course approached by some of the big tech companies during that time. And I'm like, hey, I'm happy what I'm doing. I'm good. I like what we're doing. But when Amazon came, it was a little bit different, and I'll tell you why. Like my journey is kind of from rockets to robots for sure. But when Amazon came to town and we had the initial conversation, it was about application, right? It wasn't just in the digital world. It was about true application. And if it's something that I learned at MIT is that forcing function of constraints and making something work in the real world. And also I had a giant advantage of now this actually ties e-commerce and aerospace together, is that when you're at the scale of Amazon, and you ship literally billions and billions of packages, like literally, then precision matters. Like you can't be, 9 out of 10 good. You have to be 99.99. And that's like what we think in aerospace terms. High reliability, high quality. So I knew I had an advantage there, but I was really impressed with the fact that they have purpose. They have purpose, right? And if you're listening to this podcast, no matter what field that you're in, you need three things. And I credit Pam Reeves for really sharing this with me. You need purpose, you need strategy, and you need operations. Purpose, strategy, and operations, right? The purpose for Amazon is really straightforward. To have the world's largest selection of goods at a low cost delivered right to the customer's door. That's our purpose. And that has shown that works. And when you do it well, you spin the flywheel, as Jeff calls it, and it continues to grow jobs and grow opportunity. Our strategy is actually really straightforward. Our strategy, of course, is in our leadership principles that Amazon has. But you even hear Andy talk about it. Like we tend to operate like the world's largest startup. And I like that. I like that scrappy mentality. I like the experimentalist mentality. I like the let's go build type of thing, build things mentality. And in robotics, one of the things that is very obvious, I think is obvious, is that what we're trying to do is have a world-class capability in the basics of robotics. Not the hype of robotics, but the basics of robotics. Can we move things? Can we manipulate things? Can we store things? Can we sort things? Can we perceive the world around us? And can we pack things? Just the basics. Some you might call them primitives. And in order to really achieve a world-class capability in this, you need that project context, the purpose that we have, right? So that's our strategy. We want to have a world-class capability in just the basics. And if we can eliminate the menial, the mundane, and the repetitive people, all right? So now our operations turns into how can we enable people with the best tool set possible out there? How can we create a safer environment for our folks with robotics? And how can we have our folks be more productive using that tool set? That is a really hard problem. The onus isn't on the operator. The onus is on us, the roboticists, in order to make our tools simple, not complex, or in order to make our tools actually have utility and to have the high reliability in the real world. That gains us a tremendous advantage because when we do that, that spins that flywheel back to we're getting better at the basics. Now, if you want that was a long way to get to why I get really excited and why I even took this job. You have to be able to think all the way through that life cycle. And I do believe that what Amazon is doing in robotics is truly pioneering work. And I do believe that by mastering the fundamentals of robotics through application will allow us not only to transform e-commerce as what we have seen. We've created hundreds of thousands of jobs. We've created a safer environment for our employees. We have, 1.5 million plus employees out there that we use our robotics for. But I believe that the fundamentals of robotics will actually start to transcend different sectors, whether it's in agriculture or it's in fishing or it's in automotive or it's in healthcare, that the work that we're doing, this collaborative robotics philosophy that we have, will actually start to impact these other areas. And when we do that, that's actually creating a very positive change for the world. It's allowing us to be more intelligent, more capable, and more human to each other, and still with the greatest value of human-to-human connection, with the greatest value of a person having a great job in a safe environment and allowing them to do productive things, right? That excites me. And there's no other company in the world that can do that.
Maybe the first or second time I visited you at your labs, you showed me some of the research you were doing with pick and place with robot arms, and a lot of it was based around food. You know, like you had like all these cans of groceries and everything set up around the office, and it strikes me that that's in part because of how much more difficult it is in terms of the setting, but also in terms of like the things that they're actually picking up.
People think that picking things up is trivial, right? It's easy for us. And as Hans Moravec pointed out 35 years ago, what's easy for robots is hard for us, and vice versa. Like grasping are still hard for robots. We're getting closer, but being able to do it really reliably for all kinds of objects is still a challenge. And so the home, where you have many things that are unstructured, right? If they're not in packages, then you have all kinds of things that have to be put together. And clothing is a good example, right? You know, you have clothes all over the floor with laundry, right? When you're cleaning up after a meal, you have all kinds of half-open packages and things you have to pick up. For example, look at just like you have some crackers, and they're in a package that's usually transparent, and you open that up and you sort of have what's left is a transparent wrapper. That's very hard for a robot to pick up, partly because it's very hard to perceive. If it's transparent, the typical methods of depth sensors or cameras can often overlook the object. Humans are very good at compensating, and we can see it instantly, right? It's trivially obvious to us, but that gives robots a sense of hesitation. Also, that we see that thing is an empty wrapper, so it's okay to sort of squeeze it. But a robot would look at that as sort of an odd shape, and it's not sure what to do with it. So a lot of the standard approaches will fail on just an empty wrapper. Another example I like to use is eyeglasses, right? We know how to pick them up, and it's no problem. But a robot doesn't, you know, it's very complicated because they're delicate. You don't want to put your grippers on the glass part, right? So there's a lot of nuances to grasping. That's why we study those. In fact, at the lab, we're often very interested in these.
Hello, and welcome back to Automate Live. My name is Jana Martin. I'm the Media Production Manager here at the Association for Advancing Automation, and I'm joined by my two colleagues, Alex Coleman and Aaron Prather. Welcome to the show, guys.
Thank you. Thanks for having us on.
So glad to have you here. Now, for those who don't know, A3 does a lot of different things. Of course, we're the hosts of Automate Show, but during the year, we have many different teams and we all collaborate with each other. You guys make up part of the market intelligence team. Aaron, you're the newest member to the market intelligence team, the director. Well, welcome to the team, first of all.
Thank you.
What got you excited about coming over to A3?
I mean, it is just A3 is the main location for everything robotics and automation here in North America. This is the main organization. We do everything from our team doing market intelligence to standards to marketing for everybody else. I mean, this is where you want to be if you're in robotics and automation. You want to be at Automate, and for us hardcore guys, we want to be part of A3. So that's why when the opportunity came to join A3, I had to jump at it, and quite frankly, this first week for me,
Yeah.
being at Automate has been amazing.
Yeah.
And we have some great stuff in the pipeline already.
Quite a fun week to start a new job.
Yep.
But let's just talk because maybe folks don't really know like what is market intelligence like specifically for our members. What kind of do you guys offer to the members? Alex, do you want to start?
Sure. So we offer a really great range of products, everything from our robot statistics, which are the most authoritative for North America, covering a lot of detail, all the way through to market reports, which are really useful for both people deploying automation, but anybody interested in the space. We have details on supply chains, rare earths, the labor shortages and challenges that are present there. So we really cover a pretty broad remit of everything that'd be interesting to our members.
And so just so people maybe know how to access that, once you become a member, you can go to the automate.org site, contact Amy, get your membership started. Then, depending on your level of membership, you can get an access code to then log in and download all of these reports with all of this incredible data. Okay, so let's talk about what you've been seeing. Looking at the latest data, what are kind of the big themes emerging around the automation industry right now?
I mean, it's just we're starting to see growth outside of what we would call their traditional industries. Automotive has always driven the robotics industry, and they continue to do so.
Right.
But as one thing that we've seen in the analyst from Alex is the other areas are starting to take off and are really growing. And actually, even though the numbers were down this last period, when you really dig into it, we're seeing massive growth in some very key sectors, and we will be having a life science report coming out that Alex has been working on that will show why that is happening now, why we're seeing this boom in other industries. And I think that just shows that robotics and automation is reaching out into many more industries, and it's just going to be really fun to cover those as we start getting more data of how are robotics and automation entering those industries.
Right. Well, and can you just talk about you've had a lot of reports, I would say, within the last year, 6 months. Can you maybe mention some of those just so people can get a flavor of what's already on the site?
Sure. So we've got great content. Two of the most recent ones that we started rolling out are quarterly deep dives into the material handling applications, which has just grown to become such a big presence both on the show floor and out in the market. And then another one specifically looking at Mexico, which has been an area where we've seen great growth. We had a great session for Latin American networking the other night, and so we offer a lot of content for those specific markets, but then more broadly, we continue to produce the quarterly robotic statistics, machine vision statistics. And so, as Aaron mentioned, life science is a big focus for Q1. That delivered amazing numbers in terms of market growth there. So, definitely an area we're keeping our eye on and preparing specific research to help our members understand and address that market down the road.
Absolutely. Absolutely. Well, maybe we can jump and talk about physical AI a little bit because that's been a buzzword of the year, no doubt. How are you kind of defining that? And then why do you think it's gaining so much attention right now?
I mean, physical AI, I think really when we first got the term, it was because it was being attached to humanoids. So humanoids really started opening up this idea of not only is AI going to be on your computer and help solve items and issues for you, it's now going to be into hardware. And of course, everyone's seeing the humanoid as that first thing. But what's really interesting is physical AI is going into many more non-humanoid applications.
Okay.
And we're actually going to see that be its own thing of AMRs that are smarter and can make better decisions. And just having an AMR that has an arm on it and physical intelligence on it will be something that will change the industry in numerous ways, regardless if you're putting it in a warehouse or a factory. So the whole thing is I think what we're starting to see is physical AI is a much bigger pond than what we thought it was. Everyone was thinking, oh, that's just humanoid. So no, physical AI is a much bigger. It's actually an ocean, and we're only now starting to explore it, kind of.
Absolutely. And so do you think are we just now we're in those beginning stages? Are we already seeing adoption of it? Is it out in the real world?
I think there's a little bit of momentum going into the stack, especially around NVIDIA's products. There's a lot of industry adoption from some of the biggest names through to some of the people that are just getting into it. And I think that speaks to the breadth of tools that are offered, the capabilities of those tools that are offered. And yeah, to Aaron's point, it really is moving beyond the starting place in humanoids and branching out, which actually coincides really well with some of the other ideas that we've seen play out over the last year or two, and we'll continue to see play out with cobots, with broader industry adoption, making interacting with and using robots more accessible as they move into smaller plants that might not have
Right.
a dedicated, robot programmer or robot specific workforce.
Right.
Physical AI can help make those tasks more addressable. I think it was Standard Bots that mentioned 99% of tasks aren't automatable, but they're increasingly chipping away at that by deploying these kind of tools.
Yeah, and the Standardbot group that is here at Automate actually has demoed that physical AI, and I actually got to play around with it. And yes, I quickly was able to train a robot on how to pick up deformed bags of bolts in just a few sessions with it.
And you have an incredible resume, but you are not a robot programmer,
I,
correct?
I I I will never put robot programmer down on my resume.
That's
But
amazing.
but it is, as Alex says, I mean, this is what's gonna open up those small and medium guys.
Right.
If they can program and train using physical AI, a cobot or another type of robot on how to do a mission or an activity, that's gonna be huge going
Yeah,
forward.
absolutely. Okay, let's talk a little bit about the index and robot orders. What is it measuring and what are the current numbers telling us about the market?
Yeah, so our A3 automation index is a expansion index. So for context, expansion indexes are measured against basically a baseline of 50. A reading over 50 indicates that the respondents think that, hey, something good is happening here, we're expanding. And in our case, our blended measure, which looks at a lot of various aspects, including new orders and a lot of key measures, is actually now sitting at 59.9. I think it's the highest reading in the last 2 years. So it's a really positive sign, and it's matching up for the most part with the numbers and trends. 2025 was climbing out of a little bit flatter 23 and 24. And based on the sentiment survey results, it looks like that's going to continue to grow.
Awesome. You're just checking through all the questions here. This is great. Without giving away the entire report, because we do want you to be able to download it and really digest it, can you give the audience just a sneak peek of what they might find in the upcoming release?
Yeah, so the upcoming release of the sentiment survey will continue to track these values and project them forward. We've got a lot of great respondents. It's coming from A3 membership, so it's really supply side informed, automation specific, and tailored. Yesterday, I tracked it against a few of our other measures that are commonly used, like the ISM and S&P measures, and we're finding that there's a lot of really good, consistent agreement. It's nice to see that automation isn't out on our own. But at the same time, I think the measure has a lot of value by being so automation informed, which is growing to become an increasingly important part, an increasingly important section of manufacturing.
Right.
And so that sentiment being a little bit more tailored could deliver a lot of value for people.
Now, are you seeing confidence return among buyers, or is there still a little bit of caution in the market?
Yeah, I think going into Q1, the measure showed a good bit of positivity and projected forward to Q2. It's still remaining positive, but it's, maybe not growing at the same rate that Q1 grew at. And I think a large part of that, and this is a warning sign flashing all over, is just continued concern over cost pressure and potentially a little bit of margin compression because they're seeing input costs rise, but maybe a little less ability to raise their costs and pass them on to their clients. So a little bit of margin compression there, a little bit. It's still a positive measure for sure, but it is compressing a little bit and deaccelerating a little bit.
Okay, interesting. And then we did mention already the life science report that's coming out, but can you give us a little bit more insight? Like, what can people expect to find in that report, and maybe who do you hope downloads it?
Yeah, I'd encourage anybody that's in the automation space that's interested in this potential market to check it out. If you look at building cobots and you want to understand what are some of the challenges, what are some of the regulatory factors that might make your product or your skill set attractive, check it out. It does a deep dive into a lot of the regulatory factors. And life sciences is a really broad remit, everything from pharmaceuticals to lab work to R&D. And so we're trying to give you a really comprehensive accessible survey of what's out there in the market and why your potential clients might want to buy from you. What are the pain points they're facing? And it's going to be informed by a lot of research into nowadays, for better or worse, the regulatory factors that are affecting it. So
Right.
I think it is a really positive time for automation in these spaces because of the opportunities for easing those regulatory burdens.
Right.
Regulation increasingly is encouraging you to adopt automation in this space. And so I think this report is well timed to match that.
Why are life sciences becoming such an important part of the automation ecosystem?
I think it's just because we're starting to enter this phase of where other industries are experiencing labor shortages, return on investment questions, and all that. And when you look at life sciences, there's this huge opportunity of using robotics and AI to actually accelerate on the research side, accelerate on the manufacturing side, and then even taking it all the way across in the warehousing as well. So the whole thing is this is where I think our team in the market intelligence side is really going to start looking at these other industries, that these non-automotive industries that are seeing rapid growth because they're starting to identify their use cases that they now need to go buy robotics and automation for.
Right.
So this will be one of our first reports as we go into down those non-additive, non-automotive sides.
Right.
And you can look in the data right now and see how electronics is taking off, food and food is taking off, all these other industries are taking off. So the market intelligence team will be exploring those and looking at that and providing back to the A3 membership, as Alex says, information so they can actually make decisions of how they could enter these marketplaces. So we're going to do that hard work for them and show them where they might have opportunities in the market.
Amazing, amazing. Well, that was gonna be my last question. Like, what else aside from that? Looking even more ahead. I know you just got here and you probably haven't been able to put all the plans together, but what else? If I sign up to be a member because I want these reports, what can I look forward to in the coming next 6 to 12 months?
Give us some time, but one thing, I mean, it is going to we are going to keep looking at these non-automotive areas because they are starting to be huge contributors to the overall marketplace.
Absolutely.
That's not to say we're not going to not pay attention to automotive and sensors and everything else that goes into this, but we are going to look into these other areas for our members because our members are looking into these other areas. So we need to be that tip of the spear and look into the future and come back with solid data points that will help inform them so they can make important business decisions.
Okay, I'll give you the last question. What's one metric or trend or signal that you'll really be watching closely in the next year?
I think one interesting one will be where are humanoids going to go? Because I
Yeah.
think that, there was just the recent news of Agility going public via a special purpose acquisition company,
Right.
and seeing how the public's reception is going to be to that, the public market and the public as a whole, as
Right.
there becomes increasing awareness of what these humanoids can do and where they could be deployed and how that'll play out. So that'll be an interesting open question. I know a lot of people at our session on statistics had questions about forecasts for humanoids, and
Right.
so definitely an area to watch.
Everyone wants to know. Well, you can find out from these two gentlemen. Stay connected with Aaron, especially on LinkedIn. He's always posting. And of course, join A3 and become a member and get the data for yourself. That's it for this episode of Automate Live. Thank you so much for tuning in.
This is what I have been thinking about for many years now. If your car is driving at 60 miles an hour, does the car have the luxury to wait for the clouds to tell it what to do? I would say no.
The big one is clearly TRI, the diffusion policy. That was a big outcome for us to be able to show off this ability to do imitation learning, where there is no writing of code, and you can teach the robots to do these really complex behaviors.
Can I foresee cars being made? One, they should be mostly software defined in the next few years, and can they be made in a 100% automated line without any human touch? Yeah, I can see that. I can see that in 10 years. I can't see a humanoid working alongside me in the kitchen in the next 10 years.
We're sort of defined in our intelligence by our ability to use tools, and if we look at all the ways we interact with the world around us, I don't move a pallet by lifting it, I move a pallet by using a pallet jack. Why on earth would I make a humanoid robot that's going to pull a pallet jack around? What a suboptimal use of all of that complexity and all that capability. And so I think we're going to have to kind of imagine for our industry and for our economy this portfolio of robotics that's going to do everything that we want them to do, and not be attached to the idea of a particular form factor being the right one for everything.
This is something that humans have been dreaming about for thousands of years. Like the early conceptions of a humanoid robot were like 3rd century, BC in China. I think the Greeks were even writing about things like humanoid robots. So we've been conceiving of this as humans for thousands of years before we conceived of computers.
Hi, welcome back to Automate Live. Again, I'm Jana Martin, part of the Association for Advancing Automation, and I am joined by three of my colleagues, Carol Franklin, Maren Rausch, and Aaron Prather. We'll talk about what they all do during this interview, but these folks are all involved in standards, which has to do with basically keeping everyone safe while they're using robots and automation. So let's talk about what your team strategy is in terms of developing standards. Why do you kind of focus on that international audience first?
Sure.
Carol, can you tell us?
Sure. So at A3, we've long had the strategy of do the work first in the international sphere. And what that essentially means is that we are very heavily involved in the work of ISO TC 299, Technical Committee 299 for robotics. And the reason for that is that when you have an ISO standard, then countries around the world can what's called nationally adopt them. And so what we do is we do the work first in ISO. So we develop, for example, our U.S. experts contribute to developing 10218, for example, and then we bring that back to the U.S. as a national adoption, which in our case is R1506. And our colleagues in Canada also bring back 10218 and nationally adopted as Z434, and all different countries all around the world can do that. And so the benefit of that for our industry is that when a company wants to enter one of these markets that uses a national adoption of an ISO standard, that minimizes the amount of re-engineering they have to do in order to enter that marketplace and comply with the safety standards. And actually, maybe Maren can tell us a little bit more about why the 10218 to R1506, we consider that a real success story for our industry.
An example, yeah, please.
Yeah, happy to do it. So Carol had mentioned ISO 10218. There's actually two different parts, ISO 10218-1 and ISO 10218-2 that were developed in the international sphere. And the first one addresses the machinery requirements for it as it's developed and manufactured. And then part two addresses the integration of robotics. And once those documents were developed, it was important to bring them back into the US. And as such, we have nationally adopted them, as Carol mentioned, as R1506. And what's nice is, as Carol mentioned, she's already got all my questions answered.
I do that.
But that it helps manufacturers of products to ensure that they can enter marketplaces around the world without as much re-engineering. So ISO specifically requires that no users be addressed. User requirements are not addressed in the ISO sphere. So as part of adopting the 10218 standards in the US as R1506, we actually tacked on a third part that we developed only in the US with our US experts. And that's a part 3 that has user requirements for robots. And so that is an example of when it does make sense to do the work at the national level and not take it from the international back to the national. And just as a point of clarification, when 10218 was first developed a couple of decades ago, it used the R1506 document, like 1999, or Carol can correct me, as the seed document. So it's not cut and dry that we always take international standards and nationalize them, but in an ideal world, that's what we do because it helps our customers the best.
Yeah, and the whole the 10218 ecosystem, if you will. I mean, I think it's either been nationally adopted or is used directly as the 10218 in, I don't know, 15, 18,
I
a
think
large
it's over
number of
20 countries
yeah,
now.
a large
Yes.
yeah.
Mhm.
And so, Japan, Korea, Germany, UK, Canada, US, I
Yep.
think even Brazil,
Denmark.
yeah.
Yep.
And so, that is a huge success story for our multinational constituencies that want to operate in all of those. So
Yes.
that's why we do the work first in the international sphere. And so we're taking that same approach to some of these new areas where standardization is becoming needed.
That's a perfect transition. All week here at Live, we've been next to this AMR demo area where they've really been talking about the need for interoperability, and of course, all through the industry. All of these different devices, different kinds of automation need to work in concert with each other. And so we don't currently have a standard around that. Is that correct? We're in development.
Well, yes.
Tell us more.
Well, yeah, I'll
maybe
take that one.
Carol.
Yeah, so
Okay.
so the interoperability standard, we don't have one quite yet as
But
far
it's
as being
so
published, but
close.
it's so close. So so taking the international first approach, 3 years ago, we in the U.S. championed the beginning of a project in ISO TC 299 to develop an interoperability standard for industrial mobile robots, and that's ISO 21423 is the number of that standard. And so then they created a working group 10, which has been working very diligently for the last 3 years. And what we're currently in the stage for that document is what's called FDIS, Final Draft International Standard.
Okay, I love that.
It might be better to spell it.
Sorry.
Yes.
But in the standards world, we just pronounce them. So there's the DIS, there's the FDIS. Anyway, the final draft international standard ballot. It's undergoing its ballot right now, and so we'll know within a month. And if it passes the ballot, and we are confident that, I mean, you can't count your chickens before they're hatched, but chances are good that it will pass.
Yeah.
And if it passes, then it will be probably 2 months after that it's actually published. If it doesn't pass, then the working group will take it back and refine it some more,
Right.
and make another pass at it. But so we could be as close as maybe 3 months away from seeing this thing published. And in the meantime, you actually the FDIS draft is actually publicly available. You can buy the FDIS draft if you want to see what's in this document. You can buy it from ISO. So it's very close, and we're really super excited about that because this is our first foray into non-safety standards.
Okay.
So historically, most of our efforts in the robotics industry have been about safety, because we honestly believe that safety of humans around robots is a key ticket of entry for the success of our industry. And so since 1982, when we first started the R1506 committee, really our focus has been on safety standards. But there's also a lot of other work going on in standardization with robotics outside of safety now.
Okay.
And this interoperability is one of those.
One of them. And we've added a new team member to maybe help us with this. Can you talk more about Nikki?
Yeah, and that's Nikki. And maybe in a future Automate Live, we'll have her on the stage. But Nikki Beach was brought on board earlier this year, and so she is taking over the committee management of the group working on the interoperability standard. So
amazing. So much going on. Okay, I want to talk a little bit about dynamic stability. Aaron, you're not on the standards team. We've talked, you're on the market intelligence team. But you've spoken at our International Robot Safety Conference. You've been involved in this world. So can you talk a little bit about what you're looking at here with this?
Yeah, I mean the effort is underway, as Carol's brought up, that this is an ISO effort for dynamically stable robotics. So notice we're not using the term humanoid in that. And this is, I think, a brilliant decision by the standards team, because what it's looking at is not the human form factor. We're not building a standard because it's a human form factor. It's because these robots, to stay upright and to move, must always have power. So that puts a lot of traditional robotic safety ideas into question, to say the least.
Absolutely.
So the number one way and the easiest way to explain this, and how I explain it to my family members of like why are we're doing this work on humanoids, is the big red button.
Yeah,
everybody knows the big red button, and when you hit the big red button, the robot powers down, everything stops. That's your ultimate safety thing. For dynamically stable robots, that's a problem because now when you hit the big red button, it has no power to stay upright.
Right.
Now you might have created actually a safety hazard.
Right.
So I think it's really the work that the teams are doing on the standard is going to put it there. It's going to take them probably another 2 years. Well, that's what they're working on, a 3-year calendar right now. So they're at 2-year mark left out, and we'll see how that progresses. But the whole thing is this, I think, also opens up for the world of standards of, we now have potentially 2 pathways for robots to follow: dynamically stable ones and non-dynamically stable ones. This is going to create a huge opportunity, I think, in standards world. But this is also why we always ask, we need more expert volunteers on our committees to help us explore as these technologies are changing, and we're coming up with different ways the robot interacts with humans and how they're powered and all these things. The need for more standards is coming, but we need more experts to help us on that.
Right. Yeah, and also the dynamically stable industrial mobile robot standard that we've been working on, and thank you for mentioning that. That group is, we don't have any problem with experts on that one. We have something like 169 experts on that one.
Great.
But some of the other working groups in TC 299 are working on other aspects of service robots, and service robots is, I think, poised for a massive expansion into our world. Because now the capabilities of the robots are such that they're leaving the industrial space. And so service robot safety, service robot performance and tests, those things are going to become, those standards are poised to become very important, and we really need experts in those domains to take part and help make sure those standards are the best they can be.
And I just want to take a moment and say, if you're interested in connecting, you can go to the automate.org site. You can find everyone's info here, reach out and get connected and get to be a part of that.
Yeah, and I should also mention too that we at A3, not only we manage the R15 committees, so the ANSI committees R1506 and R1508 for national standards, but we're deeply involved, as I said, with TC 299. And if you're in the US, you want to get involved in these ISO efforts, you come through us because we're what's called the US Tag Administrator.
Okay.
And that means we manage the US's involvement in TC 299. But Automate has a international audience. There are international companies that are exhibiting here, and there are international guests who are coming to see them.
Many.
And if you are from a country not the US and you want to get involved in TC 299, you can definitely do that, but you would work through your own country's standards group. So, and we might be able to direct you to where you should go to reach out to those folks.
Absolutely. I have no doubt. Y'all are very well connected. Carol travels nonstop. Okay, we're getting close to wrapping up, but I know, Maren, we did want to talk about what you've been working on, this Type B standard.
Time for that.
Let's just squeeze it in. What is this Type B standard, and why is it important?
Yes, well, the number is 25874. We don't expect anyone to remember that, but a Type B standard is one that is not as highly specific as a Type C, like the 10218 for industrial robots. So a Type B could be addressing any kind of robot for which there's not a highly specific standard, and it provides safety guidance for those robots, especially as new products enter the marketplace, and they're looking for a way to show that they're safe and don't necessarily have a standard to point to. It would be an umbrella standard for them to look at.
Well, we've barely
running out of time.
I know we've barely just scratched the surface here, but if you're interested in this, come to the International Robot Safety Conference. We'll be hosting that later this year in Detroit. All of these lovely folks will no doubt be there and be speaking, and you can meet them and talk to them and get more involved. We're so thankful for you for joining us today on Automate Live. We'll be right back with more.
Thank you.
Meet ViewPod by Apera AI. Bin picking productized. A complete, self-contained cell that ships vision-trained and robot pre-programmed. No integration project, no vision expertise required. Just connect, calibrate, and run in days, not months. ViewPod is built on Appair's 4D vision technology and expertise, battle-tested on production lines across North America and Europe. Stop planning, start picking.
Missed defects are costly. Musashi AI helps prevent them. Our Sendient software uses active eye, deep learning models to catch the defects traditional inspection misses, turning every scan into real-time insights. Our new production-ready modular platform is smaller, allowing for faster deployment at lower cost. Backed by our team at every step. Smarter inspections, superior results. Musashi AI.
The wait is over. Flexiv has just launched 2 brand new robots at Automate 2026, Enlight and Miko. From whole body sensitivity to advanced dual arm manipulation, this is what's next for automation. Head over to booth 2844 right now to catch the live demos.
Automation is evolving fast. Your design tools should too. With Onshape's cloud-native CAD and PDM platform, your entire team can work together in real time, from anywhere on any device. No installs, no downtime, no waiting. Just faster collaboration, faster iteration, and a smarter way to build products. For a closer look at the future of automation design, stop by booth 3778 and see Onshape in action.
Rittal and ePlan are live at Automate 2026, demonstrating exactly how we're better together. Don't miss your chance to experience the power of software, hardware, and automation in one system. We're showcasing live demos and real-world success stories. Come see us at booth 2818.
Well, one of the things that really interested me the first time I came and visited you over there in the Akamai building in Boston was, and maybe this goes back to the decision to remove Boston Dynamics from the beginning of the name, is that the company is relatively, or maybe entirely, hardware agnostic, right? I mean, you were buying a lot of spot robots, but you've also been buying different humanoids to test out.
We have about 50 robots here. Some of them are arms mounted to the table, like an industrial arm, which we bought from, Universal Robot. We have a couple of Unitree humanoids here. both the big one and the little one. We also have a lot of spot robots from Boston Dynamics. I think we have maybe 20 of them here. We have some Anybotics robots. You know, we don't have a direct relationship with them other than being customer, but Marco Hutter, which is one of their founders, is the director of our Zurich office. And he's working, half time with us and half time with ETH, where he's been for a professor for a while. So yeah, we're hardware agnostic, and we build our own hardware. We have, a variety of hardware activities. You've probably seen the jumping bicycle, the parkour bicycle. We have arms and hands and torsos that we've been building, and we're building more stuff.
Yeah, you've been pretty open about this too, that, you were, I don't want to speak for you, but maybe to a certain extent you were hesitant to productize because you feel like productization can kind of, in a way, get in the way of innovation.
Hesitance too weak. We are not making any products. I think that we're really trying to work on the future, the next generation after the current generation. We want to make robots really smarter, more like easy to interact with, more like people. People know so much already that the task you're giving them is just kind of fits into the world that they know about. They have situational understanding, and that's really important, I think, for getting robots to be the next level beyond where they are now. Anybody who uses a robot today finds out pretty quickly what the limitations are, and that doesn't mean they're not useful, but it's a lot of work to make them do the things that they need, that you want them to do. So we're trying to, go past that. I think when you work on a product, there's lots of demands that you don't need to be working on if you're working on the future underlying technology, like the reliability of the robot. Boston Dynamics spends a lot of resources on making their, the spot robot out in the thousands of hours of time between failures or between interventions. And, we want to concentrate on getting the new thing just starting to work.
Yeah, I suspect maybe one of the biggest hurdles there, and I'm curious, what your thoughts are as far as the Electric Atlas humanoid, but is pricing, right? I mean, Boston Dynamics has been able to build these incredible robots for decades now, but in terms of actually being able to sell a humanoid robot, you kind of have to rethink it from scratch.
Well, it's true. At the Institute, we're not worrying about how much the hardware costs to build.
Yeah.
That's another specialized skill requiring a whole system of supply chain and understanding what volume you're going to make the thing at. And we're not doing any of that. We're making prototypes that can be very expensive, and that lets you, explore more quickly than if you're trying to design a product.
What was that initial conversation with Hyundai like when you were trying to get this together? What was the pitch like? We're going to spend all this money and not make any products.
I wrote up a short document that they reviewed, and then we had a conversation. And I think they believe that investing in the future is an important thing for them to do. It wasn't a hard sell.
Yeah, it's interesting too. I mean, one of the things that I've noticed being more involved in robotics and the robotics community over the past several years is there's a sense of openness that you get in that world. As somebody who's covered like Apple for 20 years, there's a sense of openness, working with different institutes. Obviously, you mentioned ETH and you come from MIT, but there is a lot of sort of sharing of information and cross collaboration that happens.
Well, one of our goals here is to take advantage of that in both directions. I like to say that we're a halfway between a corporate lab and an academic lab. Academic labs are as open as you can find anywhere where, they want to share everything. Corporate labs usually don't want to share that much. And we're trying to be in the middle somewhere. So our people write papers, we open source some amount of work, and we're trying to take advantage of that community, help build the community. We're funding about a dozen university labs.
It does seem that way, and I will tell you that in my career I've been very blessed. Like I said, with great teammates and a great support system, and I was of course approached by some of the big tech companies during that time. And I'm like, hey, I'm happy what I'm doing. I'm good. I like what we're doing. But when Amazon came, it was a little bit different, and I'll tell you why. Like my journey is kind of from rockets to robots for sure. But when Amazon came to town and we had the initial conversation, it was about application, right? It wasn't just in the digital world. It was about true application. And if it's something that I learned at MIT is that forcing function of constraints and making something work in the real world. And also I had a giant advantage of now this actually ties e-commerce and aerospace together, is that when you're at the scale of Amazon, and you ship literally billions and billions of packages, like literally, then precision matters. Like you can't be, 9 out of 10 good. You have to be 99.99. And that's like what we think in aerospace terms. High reliability, high quality. So I knew I had an advantage there, but I was really impressed with the fact that they have purpose. They have purpose, right? And if you're listening to this podcast, no matter what field that you're in, you need three things. And I credit Pam Reeves for really sharing this with me. You need purpose, you need strategy, and you need operations. Purpose, strategy, and operations, right? The purpose for Amazon is really straightforward. To have the world's largest selection of goods at a low cost, delivered right to the customer's door. That's our purpose. And that has shown that works. And when you do it well, you spin the flywheel, as Jeff calls it, and it continues to grow jobs and grow opportunity. Our strategy is actually really straightforward. Our strategy, of course, is in our leadership principles that Amazon has. But you can even hear Andy talk about it. Like we tend to operate like the world's largest startup. And I like that. I like that scrappy mentality. I like the experimentalist mentality. I like the let's go build type of thing, build things mentality. And in robotics, one of the things that is very obvious, I think is obvious, is that what we're trying to do is have a world-class capability in the basics of robotics. Not the hype of robotics, but the basics of robotics. Can we move things? Can we manipulate things? Can we store things? Can we sort things? Can we perceive the world around us? And can we pack things? Just the basics. Some you might call them primitives. And in order to really achieve a world-class capability in this, you need that project context, the purpose that we have, right? So that's our strategy. We want to have a world-class capability in just the basics. And if we can eliminate the menial, the mundane, and the repetitive with the basics, that's going to be better for our employees. That's going to be better for people. All right. So now our operations turns into how can we enable people with the best tool set possible out there? How can we create a safer environment for our folks with robotics? And how can we have our folks be more productive using that tool set? That is a really hard problem. The onus isn't on the operator. The onus is on us, the roboticists, in order to make our tools simple, not complex, or in order to make our tools actually have utility and to have the high reliability in the real world. That gains us a tremendous advantage because when we do that, that spins that flywheel back to we're getting better at the basics. Now, if you want that was a long way to get to why I get really excited and why I even took this job. You have to be able to think all the way through that life cycle. And I do believe that what Amazon is doing in robotics is truly pioneering work. And I do believe that by mastering the fundamentals of robotics through application will allow us not only to transform e-commerce as what we have seen. We've created hundreds of thousands of jobs. We've created a safer environment for our employees. We have, 1.5 million plus employees out there that we use our robotics for. But I believe that the fundamentals of robotics will actually start to transcend different sectors, whether it's in agriculture or it's in fishing or it's in automotive or it's in healthcare, that the work that we're doing, this collaborative robotics philosophy that we have, will actually start to impact these other areas. And when we do that, that's actually creating a very positive change for the world. It's allowing us to be more intelligent, more capable, and more human to each other, and still with the greatest value of human-to-human connection. with the greatest value of a person having a great job in a safe environment and allowing them to do productive things, right? That excites me. And there's no other company in the world that can do that.
Yeah, there is this tension between sort of generalists versus specialists, and how much progress we can make on very specialist tasks using very generalist systems. In fact, recently interviewed on the podcast Sergey Levin, who was one of my co-conspirators in this journey of bringing computer vision and robotics together, and asked him, like, do you think it's a tension really that there is the specialists on one end of the spectrum and the generalists at the other end of the spectrum? His perspective was that no, that there is very much that we will end up in a place where the generalist systems are also the best specialists. That transition happened in AI, in the sense that it used to be that you build machine learning models for every specific tasks independently, right? For machine translation, for computer vision, for natural language processing. And suddenly we're in a place now with the large language models and large multimodal models where the generalists basically beat the specialists at every task, or you can turn a generalist into a better specialist with very little fine-tuning or even just by prompting the model. So that transition has happened in a lot of areas of AI. And the question today is, are we going to see this transition happen in embodied AI in the same way? And what will it take for that transition to happen? A lot of people are making the bet on it's really just a matter of scale. So we need more data, and we need more scalable ways of collecting data. We'll see if that's true. There are also a lot of bets on simulation. Like, can we do a lot of simulation and generate a lot of data in that way? I think the jury is still relatively out on what will win out, and if we're going to be in a place where specialist systems are going to be much better than generalists for a long time. But that question is a very important scientific question to be answering for the future of robotics.
Let's start off, give me the sort of standard startup intro. I'm Josh. I am one of the co-founders and the CEO of Tutor Intelligence. We are a 5-year-old startup based right here in Boston, and we build generally capable robot artificial intelligence. So that's like training large-scale robot foundation models and building generally capable hardware platforms for those models to run on. And then we also deploy robots running our software and our models and our hardware into the real world, where they can do meaningful work in, today, mostly manufacturing and logistics.
What is generally capable?
So most of the world of, I feel like, robotics that people have done to date until very, very, very recently is you find some problem, something dull, dirty, and dangerous, and you're like, we're going to go build a machine basically to solve that problem. And robotics has been, I think, a really fantastic toolkit in solving problems, in that you have, like, you can move anywhere in space, there's computer vision techniques, you can solve problems, but we're always building kind of a specialized solution to a specialized task. And in the last, let's say, 5-10 years, the sort of emergence of large-scale deep learning and more recently foundation models has made it possible that we can think about robotics not just as a toolkit to solve really specialized problems, but as a platform where we can build kind of one model, one piece of software, one piece of hardware, and then deploy that to really diverse environments. And so our goal as a business is to build those general platform technologies, and then while we're building them, deploy them and make sure they actually are economically useful and deliver more value than robot solutions that might have been built on that old paradigm of sort of very specialized systems.
Yeah, I'm curious, so that with the deployment, obviously, and this is one of the selling points, is that it is kind of trainable or at least deployable by the customer.
Yeah.
How much of what it's doing is reinforcement learning based, and how much of it is really like that hands-on that the customer themselves is actually doing and sort of showing the robot?
Yeah. So the name of our company is Tutor Intelligence, and the reason for that is the company was founded around this core technology bet, which is, hey, robotics has all of these unsolved problems. We don't know how to train a model because we can't get data in order to train that model, right? In text, you can scrape all Wikipedia, and images, you can scrape all Google Images. Our thesis was, if we can deploy robots out into the world and connect them with a staff of people, of what we call tutors, and those are basically individuals who are tasking robots, training robots, demonstrating to robots over the internet how to do tasks. Term that's come to popularity recently is teleoperation. We can both enable robots to do jobs that they haven't been able to do before, and also collect large-scale training data to train robot foundation models. So that's our primary technology tool, is large-scale behavior cloning or imitation learning from data collected by robots and sort of annotated by tutors. We also do a little bit of fleet-scale reinforcement learning, but that's actually pretty recent for us.
So So the tutors that aren't the customers, the tutors, that's an entirely different class. I don't know. These are people who you're effectively hiring in order to collect real-world data for you.
Correct.
And what is that process? And what's that relationship?
That job is a really cool job. One of the ways we hire for that job is we put up, because put up a job listing for a tutor. It's like, okay, somebody with a master's degree is going to apply, looking to teach French, but we put up job listings.
Hello, and welcome back to Automate Live. My name is Jana Martin. I'm the Media Production Manager at the Association for Advancing Automation, the host of Automate Show, and I am so honored to be joined today by our president, Jeff Bernstein. Jeff, thanks for being here today.
Well, thanks for having me on Automate Live, Jana.
Well, we're so glad for all of your support of all of our efforts to get the word out there more, and we just have to take a moment to stop and celebrate what a great success Automate 2026 has been. We had great plans and great visions for what it could be. And now standing here on Thursday, the last day, I think we can look back and say we did it.
Oh, we did it. No question about that. We did have high aspirations to reach the largest footprint of a show we've ever had, and we exceeded even what we thought was possible with 1,150 exhibitors occupying over 425,000 square feet. But the biggest goal was to reach 50,000 registrants, and it looks like we've exceeded it. And the biggest surprise to me of the week is when I walked in here this morning, Thursday, last day of the show. You expect nothing much going on. There's a line to get in the show today, and that just is a testament to the fact that Automate is a show that people want to be at.
Now, in terms of like the technology and the different talks, I mean, you go to a lot of shows all the time. Was there anything that you saw or heard this week that kind of surprised you or intrigued you?
Well, I'm certainly intrigued by a lot of things, but obviously the humanoid robot forum that we held here in conjunction with the humanoid robot pavilion that was sponsored by NVIDIA, this really was interesting because, look, we're not ready yet with humanoids, but the AI is advancing quickly. The humanoid hardware is advancing quickly. And so it may be a few years, but I think eventually you're going to see humanoids doing meaningful work in factories and warehouses, and eventually, hopefully, in our homes.
And I mean, that just goes directly into the next question. What is the biggest misconception right now about humanoid robots and their capabilities or abilities?
I think the biggest misconception is that they're ready to go right now. There are a lot of pilot programs out there, and most of those pilot programs I'm hearing are maybe 50% effective. Companies expect 99.99% effective technologies. So humanoids have a way to go in terms of proving themselves capable of being a better form factor than existing types of industrial robots. Now, the other thing is when it comes to the home. So the biggest barrier that humanoids have is safety. They're not safe enough to work around people in a factory, in a warehouse, and certainly not in a home yet. So we've got a ways to go, but I believe we'll get there.
Yeah, and we were just talking earlier on this desk with the standards team and kind of that whole idea of the humanoid robots don't have an e-stop. And so you can't just stop them. We need to figure out that solution before they can really become broadly applicable in
Yeah.
the world. Um, Physical AI, no doubt, is going to be a key part of making that possible. But we found out also that physical AI doesn't only have to do with humanoid robots. When you hear about it and you're looking at it, what does that actually mean in practice, and how do you see it changing automation in the next few years?
A lot of people are confused by the term physical AI. For me, it means, look, the physical world is taking advantage of the increasing abilities of artificial intelligence. So traditional industrial robots are also taking advantage of AI. Recently, there was a series of videos online from one of the humanoid companies. They showed over a couple of days their robot showing how it could sort packages. The next day after they showed it, a company that's doing that in the real world with traditional industrial robots showed what really is involved when you sort packages at a major user company. Very different than what the video demo from the humanoid was showing.
Sure.
We've got a ways to go here, but as machines get smarter, as robots get smarter, they're going to learn on their own how to do things better. And to me, that's what we're talking about with physical AI. Machines actually getting more capabilities and adapting more so than they've ever been able to in the past.
And we really need more machines with more capabilities. This ties next into the whole workforce conversation. News reports, people talking, people are worried about jobs and automation. That's something you hear all the time. Why is that actually not going to be an issue?
Well, we certainly hope it's not going to be an issue. I've been hearing about robots replacing people since the day I started 4 decades ago. And we never saw this happen. Robots were going to take everybody's jobs. AI was, this is back in 1983, Jana. And that didn't happen. In fact, what did happen, and we've tracked this over 3 decades, is that whenever robot sales went up in America, unemployment went down. And when robot sales went down, unemployment went up. And why is that? It's because if you're not able to remain globally competitive, if you're not using the best technologies, which robots often are, then your company is no longer able to compete. And then all the jobs are at risk because other companies in America and around the world are investing in automation. And so that's the biggest threat. And I think going forward, we're going to create all kinds of new jobs that we can't imagine because of AI and robotics. The other problem we have right now is a shortage of skilled labor. In manufacturing, there's nearly 500,000 open jobs right now in manufacturing alone. That is expected to grow possibly to 1.3 million or 1.9 million by 2033.
Wow.
So how are we going to do the work necessary? Who's going to do the dull, dirty, dangerous jobs? It's going to have to be automation and robotics.
Absolutely. Now let's take a little step back and talk about the association. We're a trade association with the goal of supporting this industry. We're membership based. So talk about just the breadth of what we do. We don't just do this event. We have a lot of different things going on. Why should people come to A3 and be involved in what we're doing?
A3 is the largest robotics and automation trade association in the world. We have more than 1,450 member companies in 35 nations. So we're not just an American association. And this trade show is our biggest activity and obviously supports our other activities. We're a not-for-profit organization, unlike many trade shows that are run by for-profit organizations. So I want to make that distinction. Our job is to promote the technologies that our members provide: robotics, machine vision, motion control, AI, and other automation technologies that are transforming our world. We want companies in this space to join A3 so that we have a larger voice when we go to Washington, D.C., or when we are trying to tell companies who aren't using automation yet why they should do so. That's a big role for A3, is to educate.
Yeah.
And you mentioned standards development. You mentioned market intelligence programs that we have. We are a very active association with a staff of more than 54 people right now. We keep adding new people every day. And it's a very exciting time in automation. Robotics is at the forefront of it. And I would encourage everybody out there listening, if you're not a member organization in A3, you should look at that.
And you can go to the automate.org website and you can, even without being a member, find incredible resources. We are always doing webinars. We have other events throughout the year. And we're just really looking at trying to educate and encourage people to learn more about automation. Now, you're also doing that at a much bigger level. You mentioned the work in Washington, D.C. For those that maybe haven't heard about it, can you just tell us a little bit about what you've already accomplished on the Hill?
Yeah. We started an advocacy committee 2 or 3 years ago with the goal to get a national robotics strategy for the United States. Our message to the government was pretty simple. You've fallen behind China. They're way ahead. They're installing more robots every year than anybody in the world, 9 or 10 times more than the US. And it's a shame because the technology was invented in the United States. We went to government 40 years ago and said, you're going to lose out to Japan. And we did. Japan became the leader. Now China is the leader. They have a national strategy like Japan did. And they keep updating it every 5 years with new plans. So if we're going to be competitive in robotics, we need a national strategy. And this message is starting to resonate. There are bills being introduced. There's discussions about possible executive orders. We had here at Automate Bill Guderra, a senior executive in the Department of Commerce, and he was speaking here. They are committed. Things are happening. And I'm in Washington almost every other week to talk to policymakers about what they can do.
Now, why is a national strategy important? What is that in practice going to do for the people involved in the ecosystem, as well as the people looking to enter?
Yeah, our
automation?
vision for a national strategy is that, first of all, we need a central robotics office in the government so people know who to talk to if they have issues and they want to go to somebody and say, hey, this would help the industry. Second, we need to incentivize adoption. Everything the United States wants to do, reshore manufacturing, make our companies more competitive. Adoption is the key. Have companies set up manufacturing here of critical components. We need more adoption in the US. Third, the government needs to use more robotics and automation. They're using it in defense, but what about in their own manufacturing and warehousing activities? Fourth, we've got to train the next generation of workers. We talked about that labor shortage. Fifth, We've got to continue to invest in educational research, but also commercial research. And finally, we talked about standards, and we don't have enough in safety right now in humanoids. Maybe NIST and other government organizations can say, look, we need these standards. You organizations need to come together and make this go faster. It's happening too slowly. So those are the kinds of things we're recommending. Those are the kinds of things that are resonating with government officials, and I believe we're going to make progress here very quickly.
What do you think is different about now versus way back when? Why is there more reception to it?
I think the biggest driver is China.
Yeah.
They've seen what China has done. China saw the future. We didn't. China now is all in on humanoid robots. If they're right, and that's the form factor of the future, and I say if, because we don't know yet, we want to make sure that we're up there competing in that area too. But traditional robots even, we're so far behind even though we have all these major companies. So we need to get our act together a little bit.
And so, and as it continues, what are kind of the next steps that you're looking at? What's coming up imminently in this world?
Well, we work very closely with the Congressional Robotics Caucus. On July 13, we'll be holding a meeting with the caucus on how to build a resilient domestic supply chain for robotics. And we have a great lineup of speakers, and we'll be posting that on our website soon.
In 3 years from now, what do you hope success looks like in this realm?
Success looks like the government decided to enact legislation that would lead to America becoming stronger in robotics. And some of the things I just mentioned, and there's a National Commission Act being introduced in both the House and Senate, and maybe as part of the National Defense Authority Authorization Act. So even starting there with a commission to make a strategy would be a huge step forward. But we need bipartisan support in these areas. We need everybody out there to go to their congressional representatives and say, hey, we need this. Vote for these. I mean, make sure your representative is supportive of this.
Absolutely. Okay, now looking forward, we're nearing the end of the show. It's been so great, but the fun doesn't stop here. We have other events throughout the year. You mentioned the Humanoid Robot Forum, which was separate. We've brought it into this event. Another event that we've done in the past has been a more AI-centric event. And so we're really excited to be doing the Advanced Vision and AI Conference in Santa Clara this September. Why do you think that that's such a key part of the automation ecosystem?
Those are critical enabling technologies for robotics and automation. Vision and AI are what make these things work.
Absolutely.
And so that conference is really important to us. And so we hope everybody watching will be there.
And again, the IRSC, the International Robot Safety Conference, is also coming up. But of course, we want to know about Automate next year. We're going to Las Vegas. What was kind of the decision point in taking the show to Vegas?
Well, there were two things. Number one, we've been in the Midwest for a long time, and the show is done extremely successfully. But what you notice is over time, there are a lot of regions of the country that don't send people here. Almost every major trade show is 60 to 70% of the audience comes from within 300 miles, so it's driving range. Well, that means the West Coast isn't driving here. Yeah. So we're excited to go to Las Vegas because, first of all, we might reach new audiences. That's the plan, to reach new industries, you know, aerospace and energy and all kinds of others. Also, Las Vegas is an exciting town for trade shows. The Consumer Electronics Show, huge. PAC Expo in Las Vegas, huge. We think Automate can be that as well. And if so, we have room to grow there the same way we do in Chicago. You know, as we get bigger, there's only a few types of convention centers that can really house this event. And Las Vegas is one of them. And the reaction to it in the signups for next year here at this show has blown us away. We've already signed more exhibitors for next year's show than we did at the show in Detroit for this year's show. So we're leaving on a high.
We're so excited, and we can't wait to see you next May 10th through 13th in Las Vegas. Again, thank you so much for joining us here on Automate Live. I'm Jana Martin with Jeff Bernstein, and we'll see you later.
Well, just give me the standard startup intro. Who are you? What do you do? Why are you here?
Yeah, absolutely. So I'm Tyler Bouchard, CEO and co-founder of Flexbotics. We've built an autonomous manufacturing platform. I can give you a quick rundown of a little bit of our story and why we're here, why we've built what we've built, and maybe a little bit on what we're looking to build
All
as
of the
well.
above.
Yeah, absolutely. So myself, engineer by trade, went to if you know the Boston area, a school called Worcester Polytech. So it's right outside of Boston. So got my mechanical engineering degree there. That's where I met our co-founder as well. So there's two Tylers, Tyler Medelsky and myself. So as we met at undergrad, and we both went off into industrial automation and manufacturing space. So a little bit different angles and perspectives though. So myself, I went into more commercial roles. So I went right into sales, and I worked with companies like Cognex, did a short stint at Mitsubishi Electric, and then also Novanta. So I got a really good perspective of the complex buying processes of manufacturers, the various stakeholders within the manufacturing process, buying process.
The business side of things.
Yeah, much more the business side of it, and then got a really good lay of the land of the industrial automation space in general, who the players are, where the technology was at, and all of those details. I also sold into the motion control assembly aspect of the business directly with robotic OEMs. So that really helped me get in depth and understanding of all of the different robotic OEMs that were in the space as well. And that's actually what led us to kind of starting Flexbotics. Was we saw there was a vector into the manufacturing, very difficult to break into manufacturing, but saw with Universal Robots and their collaborative robot technology.
Because it's the most mature, established space for robotics.
Yes, yeah, exactly. I think that's one thing that I think we'll say the common person doesn't see as much, as that robotics has been around since the 80s and whatnot. So very, very established. But the approach that UR had was really, I would say, unique within that. And it's not just their collaborative nature, it was the actual behind the software platform they had, an SDK, that really allowed groups with lean resources like ourselves. We say like two guys and a dog to kind of
two Tylers.
Yeah, two Tylers and a dog to build out.
We're going to need a minimum of 3 Tylers to get this thing over.
Yeah, the dog wasn't named Tyler, so we had some variety there. But yeah, so allowed us to be able to work in a really much more lean environment. And just kind of the general things of getting your feet wet running a business. We were first-time business owners, so there's a lot to learn within that. So we were able to start building that out, start building point solutions that we could deploy into the market, start kind of building some of the thesis that we had around that. And it was around that same time, went to Northeastern for my MBA, and they have a great program called the IDEA program. It was, it is what it is. It was basically that we took our idea and kind of manifested it more into a full business plan, and then they provided basically non-equity binding grants.
So it's kind of like an incubator?
Yeah, it's like an incubator. It was kind of the reason why I went to do my MBA at Northeastern. That's what stood out to me within that program. So yeah, they bring groups from people that have all sorts of ideas and everything. The ranges of like I have a concept to like us where we had some customers and we were looking to figure out how to be able to scale it and also be able to raise capital. And they helped with all of that and put some money into the business, and then actually helped us find our first investors as well. So I like to say it's money very well spent. I don't mind paying off.
Hello, I'm Jana Martin, Media Production Manager for the Association for Advancing Automation, and I'm so excited to be joined today by Professor Jim Devaprasad of the Lake Superior State University. Jim, thank you for being here today.
My pleasure. Thank you so much.
Now, Jim, one of the reasons we invited you to come to the desk today was we gave out an award we do every year at Automate, and it's for the Educator of the Year. And this is not an easy award to get. There's so many educators doing so much great work work.
Yes,
But
true.
we really were excited to acknowledge all of the work that you've done in your career. What does that mean to you to receive this honor?
Oh, well, to put it mildly, first of all, at the least, I'm so humbled and honored, especially this particular award coming from A3. And why do I say that? Is because, all my career, I mean, like Space State University is the first university to start a robotics program 41 years ago,
Yeah.
and I joined 40 years ago. And we really didn't have anybody to look at as to what should we do in a curriculum. So what we ended up doing, going back that long ago, is reach out to industry and say, hey, we ended up starting a robotics program. What do you guys need? How should we set up our curriculum? So
Cool.
so with regards to what it means coming from A3 is the fact that we've been striving always to make sure that industry connection is there. And who better to be recognized than A3, the largest, association for robotics and automation North America, and all the wonderful things, including Automate, that's happening.
And so many great robotics leaders have actually come through your university, and so thanks, no doubt, to that program that you started.
Thank you.
We're a part of the founding of maybe 40 years ago. You said that's amazing.
Yeah.
Back then, what did you hope success would look like in the future, and did that come to be, or has the journey kind of changed and meandered along the
It did
years?
meander a little bit. First of all, the hope was this is an up and coming field, so we want to be at the front end of it to put out graduates to meet the industry needs.
Right.
But what happened was 40 years ago when robotics was catching on and getting attention, too many people jumped on it rampantly. At the result that robotics actually it didn't do well. There were no shall we say technically skilled people to implement robotics in a way that it'll be successful. So it kind of like took a little dip. People are unsure, is this another fad?
Right.
Things like that. So we went through those experiences, but we stuck with it because our graduates continued to prove themselves. Because when we talked about the award, I really truly believe the award is a recognition of our alumni out there. Like you said, we have
Yeah.
about 1,000 of them, I would say. I just kind of did an estimate, and working specifically in the robotics
Wow.
industry. So and then what happened was it kind of went into other areas, where now at Lake Space State, at least we also offer degrees in mechanical engineering, electrical engineering, mechatronics, and so forth. And in all those degrees, the students can do a concentration in robotics.
Okay.
So we're able to get more and more, because what happened, as we all know, as evident from the attendance at Automate and other things, in the 2000s, robotics really entrenched and
Exploded.
it exploded. Yeah, exactly.
Absolutely. Now, for your own personal journey, what first interested you in robotics?
Interesting point, because I did my undergraduate in India in mechanical engineering.
Yeah.
And I remember reading in those days in newspapers and stuff about this thing about robotics, and I wanted to learn more, and so I did not. There was obviously with the with the extremely high population in India, you better not talk about robotics. There's a lot of people to do manual labor and stuff.
Right.
So the only place I thought I could come to learn more was, a few places in United States offered at the University of New Mexico a robotics program at the master's level in the mechanical engineering department. It's a very good fit. I also had family there, so I ended up in Albuquerque, and then from there, I loved teaching when I was a graduate student. And then Lake State said, "Hey, we're starting robotics." So it's just purely, how it is. And often in
Yeah.
our careers, we just right place, right time.
You
Maybe
find your way.
yeah, you find your way.
You've already mentioned maybe a little bit of this, but I'll ask you again. This robotics program was brand new. There really weren't any others to launch. So were there any challenges maybe that you faced in those early days of trying to figure out what this should look like?
Yeah, it might be hard to believe this, but in the mid 1980s, the hard thing was when we had the program and students graduated and they went out looking for jobs, industry still weren't using robots, or they were like,
Yeah.
"You're a robotics graduate, graduate in robotics engineering technology. I mean, what are we going to do with you? We don't have robots in our company."
Wow.
So we got a panic attack in terms
Wow.
of what are we doing? Are we doing a disservice to these graduates?
Right.
Because the cover says robotics, although the internals were they were technically savvy in mechanical, electrical, computer, all those things.
Right.
But when they says robotics, that was our biggest challenge initially when the
Yeah.
graduates went out.
Can you share a success story maybe of a student who did see success? I mean, no doubt you've seen so many hundreds of students come through, but what makes you really excited when you see them succeed?
Yeah, a student. I mean, yes, that's the most heartwarming part
Yeah.
is to see the graduates go out, get great jobs,
Yeah.
and over a long career of mine, it's absolutely great to see them move on in their careers in the career ladder, and some of them are even retiring, and they're asking me, when are you retiring? So, but what I was going to say, if I, since you mentioned, is there any student or two?
Yeah.
Again, like I said, I have so many have
So
done so
many.
well, but one when you mentioned the first person that popped out of my head, I must say, is one of my students graduated 10 to 12 years ago, actually, in that time frame. Her name is Stephanie Peck. The cool thing about her is she came to Lake State as an 8th or ninth grader to do our Women in Technology summer camp. And she had no, she was a brilliant kid at that time, and she was not sure what she wanted to do and whether engineering is it. She said, let me go to this robotics camp at Lake State in the Women in Tech program. And then she did the week-long resident program, and lo and behold, a few years later, she shows up as a freshman,
Wow.
and then she graduates with mechanical engineering, the robotics concentration. And then she interned at GE and then Procter and Gamble, and ended up as a full-time engineer at Procter and Gamble. But the cool thing right now is she's been working about 10 years in Amazon Robotics. She's a program project manager. She's
Wow.
involved in autonomous mobile robots. She's involved in AWS infrastructure, doing some amazing things in Seattle, Washington. She also travels around the country. So it's a cool thing to see when
That's
somebody,
amazing.
the impact that it kind of had. We never thought we'll have a
And
situation
what
like
I hear there too is I think oftentimes when we're thinking about our careers, we're thinking about, okay, what are we going to tell college students about what they should study? But what you're actually saying is it starts before then.
Yeah.
Even though you're at a university, you all see it's actually the middle schoolers, it's the younger kids. You have to catch them early so
Right.
that they know kind of where to follow their trajectory.
Yeah, or what not to do.
Okay, yeah.
Right, I went to
Yeah.
this camp in robotics and it was like,
And it was
not for me.
Yeah, right.
Yeah.
What skills are you hearing now from employers that they're really looking for, that they need the students to have? Because this industry, automation, is just changing constantly.
Right. So I'll always say the underlying skills, no matter what field, is the soft skills.
Yeah.
Teamwork, communications, working, and then other things like critical thinking, analytical thinking, judgment, leadership, adaptability, those kind of things, which a good college program should provide those just for the fact that the students are there. As far as technical skills, for sure, everybody is kind of wondering, you know what I'm going to say, AI.
Yes.
What is happening and how is robotics? And in my opinion, apart from the traditional things like robotics programming, PLCs, machine vision, simulation, all that stuff,
Yeah.
I think robotics, honestly, I believe is in a beautiful sweet spot with AI, because I don't think AI can replace anybody with the robotics engineering skills. At the same time, AI is coming into beautifully to address some aspects of robotics, which is essential that you have to adopt. It's a good balance
Right.
that, because AI is not going to be able to do systems integration, but you
No.
can do robot programming with AI skills. You can do simulation with AI. And so you use those, and then robotics engineers can pull together. So I think the integration and understanding and using software to control and bring everything together is
Yeah.
really what sometimes industry calls it controls engineering. And I
Yeah.
really see that's a big need in that area with AI on top of that.
Yeah, such a complex but exciting new kind of
Absolutely.
technology to use and apply. When you look at the challenges that manufacturers are facing in finding skilled talent, what kind of roles do like competitions, industry partnerships, real world projects play in creating excitement and preparing students for entering this world?
Yeah, I think the way for the students to learn real world skills is to actually do something right at college, like we do industry-based senior design projects.
Yeah.
We also set up and encourage them to go and do internships so they
Right.
get that hands-on and this technical skills.
Right.
And then, of course, our courses at Lake Superior State University, at least 75% of our courses have a lab section.
Mm.
So we have the students actually get to work with it, and we have small class sizes. So they have a good opportunity to learn a lot of those things along the way to be better prepared. And some of our heartening to hear from our employers that, hey, you guys and gals can hit the ground running.
Yeah.
Which is very important.
Right. That's what they need.
Yeah, right
They
now.
want that ROI
Yeah,
immediately.
exactly.
And then when you think about like the educators involved, like what would you say like to them, like folks looking into getting into education and automation and robotics? Is there a need for more?
Oh, absolutely. I mean, we have a situation, I'm just extrapolating from there, that on an average, a student gets 3, 4 job offers 6 months before graduation. And the employers, even during Automate, I've had companies come and say, any more graduates looking for jobs? So,
wow.
Yeah, there's no doubt there's so much need. And educators, if they can take this balance I just mentioned about the soft skills and the technical skills and the hands-on skills, that really makes the case, I think. So I always say textbook, keyboard, wrenches,
Oh, I like that.
right? All put
It's
together.
all necessary.
It's a winning combination.
Yeah.
And you, while still maintaining your accreditation standards and theoretical aspects of a good
Absolutely.
curriculum.
Absolutely. As you look forward to the next few years, what do you hope to see robotics education continue to develop into?
I think the aspects, like I said, making sure there is a tendency, and there's nothing wrong, that there are programs that you go into very much the theoretical stuff. It's fancy and fun to go develop new robots that can walk and jump and flip, which is
Yes.
much needed. You
Yep.
got to do those research because that leads to some actual practical implementation.
Absolutely.
At the same time, I think there's enough technology out there that we still like what A3 has brought together here, 1100 exhibitors. If you really ask, on an average, a majority of them would say we want somebody who can actually get things to work, implement systems. So educators in the future, they're aware of that. There's a huge need at all levels, everything from high school, associate's degree, bachelor's, and beyond.
Yeah.
I think it would be really good. And one thing we say at Lake State is we don't make great robots, we just make robots great.
I love it.
So it's just because there are enough and more technology and robots,
Yes.
let's put them to work.
Apply it.
And make, be economically profitable for the
Right.
companies and for the
Right.
US to lead in the world in a lot of these manufacturing
Absolutely.
areas.
Absolutely. If you could give one piece of advice to students who are considering a career in automation, what would that be?
I do not be afraid of getting your hands dirty to go in and actually try things, and don't don't think robotics is all fun and play. There's some learning that has to happen, some work ethic that
Right.
goes with it. And then don't forget your soft skills in terms of working well with people, relating well with people, being adaptable, listening to technology and where it's going, and taking opportunities like Automate or A3's webinars. A3 has so many opportunities, and I'll tell the educators that's one important thing. I would tell educators is if you're not a member of A3, consider that seriously because that's benefited us immensely in
That's
Lake State.
amazing. And you've been to Automate Show before. Why do you continue to come back to this show?
One definite reason is alumni expect us to be here and they say, where are you? You better be here because of the number of people here. There are many things actually, Jana. Things like senior design project ideas, placement and recruitment and internship, networking with industry professionals, getting input from them as to, hey, this is what we're doing in our curriculum. And just so many aspects. And with Automate continuing to grow, it just seems like, whoa, if we are not there, what are the consequences? So
I love it.
yeah.
Well, Jim, we're so excited to celebrate you as the Educator of the Year.
Thank you so much.
It's been an honor to speak with you today, and we look forward to more. That's been it for this episode of Automate Live. I'm Jana, and we'll see you next time.
Thank you.
Meet ViewPod by Apera AI. Bin picking productized. A complete, self-contained cell that ships vision-trained and robot pre-programmed. No integration project, no vision expertise required. Just connect, calibrate, and run in days, not months. ViewPod is built on Apera's 4D vision technology and expertise, battle-tested on production lines across North America and Europe. Stop planning, start picking.
Missed defects are costly. Musashi AI helps prevent them. Our sentient software uses active eye, deep learning models to catch the defects traditional inspection misses, turning every scan into real-time insights. Our new production-ready modular platform is smaller, allowing for faster deployment at lower cost. Backed by our team at every step. Smarter inspections, superior results. Musashi AI.
The wait is over. Flexiv has just launched 2 brand new robots at Automate 2026, Enlight and Miko. From whole body sensitivity to advanced dual arm manipulation, this is what's next for automation. Head over to booth 2844 right now to catch the live demos.
And welcome back to Automate Live. Nikki Gonzalez with Automation Ladies here, back on the very last day of the show. Wow, it has been a show. I haven't been to all the booths like usual. So I'm really excited to talk to our guest today, Sharon from SICK. Welcome.
Thank you.
Thanks for coming on Automate Live. And I'm going to need you to tell me about all the stuff because I haven't been able to make it over to your booth yet. But I asked before, should I even ask who SICK is? Because having been in this industry for a long time, they're some, well-known entity to me as a sensor company. But why don't you go ahead and introduce yourself and SICK a little bit to those maybe that don't know who it is? Because this show keeps growing every year. We keep drawing new crowds, manufacturers that maybe haven't been, here. So yeah, please tell us.
Absolutely. Yeah. So SICK, maybe myself first. So my name is Sharon. I'm a systems application engineer at SICK. I've been with SICK for about 3 years now. And I mainly work in the robotics team with SICK. So think when we work with 6-axis manipulators, 4-axis manipulators, or when we work with autonomous vehicles like AMRs or forklifts, right? Adding sensors to automate these different solutions is where I mainly focus on, right? So that's vision, think 2D, 3D vision, think LiDAR-based solutions, code-based solutions, localization, all of that comes under robotics. Anything, any sort of sensors that can help automate systems is where I work on, right? To talk a little bit about SICK, SICK is a sensor manufacturing company based in Germany. We have our US headquarters in Minneapolis with offices in Detroit, Boston, Fremont, California, and Minneapolis. Yes, the headquarters.
Yeah.
So we have around 40,000 plus sensors out there. So
Wow.
I don't even know all of them. I haven't worked with all of them. That's a lot of sensors. We focus in areas in safety. We focus in robot guidance. We focus on control, quality control, inspection, dimensioning, measurement type of applications. So really, if you need a sensor for anything, I'm pretty sure SICK has it in their portfolio.
Yeah, I was pretty surprised to see that I would be interviewing somebody that was a robotics engineer at SICK because, again, I'm so well known for sensors.
Yeah.
But it makes sense. I've always known like that these sensors are what is used in a lot of the mobile platforms, a lot of the robotic platforms. But this time, you guys are actually integrating and providing robotics as well. Is that correct?
That's correct. Yeah. So SICK mainly, like I said, sensor manufacturing company. So we sell individual sensors, right? But with robotics, you can't just have a vision system and be like, robot go pick and place, right? There's a whole system that's involved in it. You need to have the right end of arm tool. You need to have the right safety, the right the vision concept set up correctly. So there's a lot that goes into a robotic system to make it actually do the task of pick and place. Unlike maybe having a photo eye or an ultrasonic sensor or something like that. That you place a sensor, it works, it does its thing, it gives you the data. Robotics is just a little more involved than that. There's a lot more components to actually make the application work. So what we've with SICK, and this is new for us that we're doing this year mainly, is we're starting to do turnkey solutions.
Okay.
So we're really doing the end-to-end, right? And it makes sense for SICK because SICK is that one-stop shop for everything sensor, so safety, vision, again, all those different components that I mentioned. So why go to different vendors and have to figure that out when you can just come to SICK and we do that entire design for you, right? So we have two types of turnkeys that we're providing, and we have demos of this at our show. So last day, I understand, but please, make sure to come by the
this
booth.
and you're on the floor,
Yeah.
go see the main SICK booth.
Yeah,
You guys are also located in some other places, right? Have people in the education space.
Exactly, the education space, and we have a couple of other booths that are showcasing SICK Vision as well, both in the North and South Hall.
Okay.
So definitely stop by to check them out. So yeah, coming back to the turnkey, so we have two types of turnkey that we're providing. One is a depal solution, so that is depalletizing of boxes, so mainly targeting, so think food and bev industry where you see a lot of these boxes, but that's also surprisingly the industry that does not do a lot of automation with robotics.
Okay.
So when we started doing that kind of analysis, we noticed that it was kind of an intimidating topic for them because they're like, yes, we want to bring in robots, but what next? How do we do it? Is it just a robot? Like what vision? Oh, now there's safety. Oh, there's risk assessment. So it started to become a little bit of an intimidating topic for them.
Yeah.
And they didn't know who to go to, what's the right vendors. So when we then decided that, we're going to do turnkey for customers like that, it was received very well because, like I said, one-stop shop, and we do that entire design for you, right? So turnkey depal, we're using a 3D PLB vision system. We also are providing the safety concept for it. So we based on the cell and what you want to do we have AMRs? Do we have conveyors involved in it? Is it just a simple pick and place? Like, what is the application? We designed that system for you.
Yeah.
We designed the safety concept. So should it be LiDAR, scanners, safe RS? What does that look like? We do that. We do the risk assessment. We are robot agnostic, so we can choose a different robot depending on the needs of the customer. But if you give it to us, we would go for it with a specific robot. The gripper, all of that is decided and set up for you, right? So at the facility, you just go. You have this one system that kind of opens up, expands out, and that's it. The system's ready to run. We also have a user-friendly HMI that gives all the needed details. Without all the fluff that might confuse you and make it a little overwhelming. So it tells you which cell is being built, what's the status, which layer I'm at, things like that. So there's a lot of details you can set up in that HMI as well. Touchscreen, very easy to set up.
Yeah.
Right. So that's the first turnkey solution we have. The other turnkey we have is our collaboration with Feed-All Systems.
Okay.
So we noticed a gap in the 3D bin picking space. Like everyone wants to use 3D bin picking.
Yes.
We have these deep bins with really small parts that they want to pick, and then they get mad when we can't pick like 100%, and they're like, oh, it's the vision's problem. But if you truly look at it, most of the times it's a physics problem.
You have
these
corners, deep corners of the bin
Exactly.
and the end effectors, and how do they get in there?
Exactly.
Yeah.
And then, even some of them, like if you think about springs or O-rings, they can kind of tangle up with each other.
Yeah.
And then now I'm picking a bunch instead of picking one. So now you have to have a different setup, a second stage to maybe separate them, things like that, right? So at one point, you are now fighting with the laws of physics.
Yeah.
And there's only so much vision can do at that point, right?
Yeah.
So we noticed that gap, and when this collaboration with Feedall came in, we was like, it was kind of like an aha moment, because it's not a very new state-of-the-art tech or anything. It's something
No.
very simple.
Mhm.
But the fact that when we fit it in this scenario, we're solving a really huge gap that was
Yeah.
there in this 3D bin picking space. So what we are doing is, we have a feeding system, so a hopper. You can have a hopper, no hopper, depends on how you want to do it. We have a feeding system where we can change the mats, we can change the vibratory needs of the feeding system, use a backlight, have additional illumination. You can set that up the way you want that to be. We have different sizes of feeding systems depending on the parts, the weight, things like that. And what this does is it essentially separates the parts for you. And now that the parts are singulated and separated, we can use a 2D vision system,
Yeah.
which is much easier of a tech to use and play around with and set up. Lower cycle times,
Yeah,
faster cycle times, yes, because it's a 2D system now, right, rather than 3D systems that typically have higher cycle times. So it's a simple solution with 2D, a feeding system of any size. Again, turnkey, so we do that entire build for you. We decide which camera goes in, how to set it up. We also integrate all of these components with our SIM 1012 controller.
Okay.
And again, all of that is already programmed and set up, and we have a very easy to use web-based UI.
Yeah.
So no IPC required for that system. You can plug it to your iPad, your laptop, just to review what's going on. That's how the system is built. So it's super simple, but solving a really challenging aspect that we face often with 3D bin picking. And this can often be switched with 3D cameras as well, depending on the parts that we're working with.
Okay. Yeah, I feel like when I first started coming to Automate, cobots were kind of dominating, and they were one of the newer things. They weren't new.
Yeah.
But everybody was kind of coming out with their own cobot, and it was like some of us were walking around a show going, okay, how many? There's like 10, 20, 30, they're just proliferating everywhere. But most of the time you were just seeing the arm itself.
Yeah.
And I heard a lot at the time, kind of manufacturers going, okay, we need one of these. They're now accessible enough. They're inexpensive enough. We want to get one. And then they would get one, and then they're like, okay, now what do we do? Or we thought it would be good for this application, but we didn't know that we needed to account for the safety study or the end of arm tooling or just all these different things. And I think over the last few years, it's really been A, kind of an education, but B, I guess the maturity of the arms themselves and how easy they are to get now. Then it's really the integration that's become the problem. Everybody knows that they can use them. They're just not quite sure where and how. And I think the traditional integration route, although is very good for a lot of companies, particularly bigger companies that have established integrators that they're used to working with, but for maybe somebody kind of in their first foray into it, or they've stayed away from doing, let's say, depalletizing in an automated way because they may not have the engineering workforce on site, having something standardized that they can walk into, look at. Obviously, it's going to need to be customized a little, right, per application, but you have these standard building blocks that are all proven.
Mm-hmm.
How much does that shorten, you think, kind of the time to value with one of these systems versus picking your own cobot and then trying to go and figure out, okay, what comes with it, or going the traditional systems integration route?
I think significantly, right? Like, it reduces the amount of time it takes to build a system like that significantly. It reduces the manpower that's involved in it because the decisions are now made by SICK to design that. And if we were to, and I think this is another key point of these turnkeys that we're providing, is if it's one of the systems that we have that you see at our booth, which is most of our requests that we're getting, our turnaround time is 4 to 6 weeks for the whole system, right? And then it's all built ready. You just put it on the shop floor and plug it in, start, and it works, right? And this is safety, vision, all of that combined. The risk assessment's done. So definitely significantly reduces the amount of time it takes from planning to actual executing and having it on the floor running. So definitely a huge, and it's 90% done. Yes, like you said, there's that 10% of fine tuning depending on the application, but 90%, all of it is complete. It's done. It's ready and decided for you.
Okay, so somebody can also get a pretty good idea of the ballpark price before they ever start customizing it.
Correct. Yes, because we
Okay.
do have these, like you said, the components already ready, so we can give you like a rough range of what it would look like. For the DPAL, like I said, it might change depending on whether you have conveying systems now, do you have an AMR involved in it, things like that.
Yeah.
But yeah, you would get a ballpark idea of what the
And
cost would be.
what does that process look like if somebody goes and sees one of these, let's say in your booth today, or we'll talk about where else people can see these going forward if they're not here or they ran out of time, because we're on the last day of the show. Do you guys then, kind of take the parts that they're going to be testing? Do you test it in the lab in order to, how do you figure out the rest of that 10% and work with somebody that wants to make sure that they've got the right thing for their application?
Yeah, so a little different for the two. The DPAL system, because we're depalletizing mostly cases, boxes, things like that, we don't need to do any testing. We are very confident in our solution, and it's a very stable solution for an application like that, right?
Yeah.
So it would just be reaching us to us, we create a project out of it, and then we start the planning from there. So directly reaching to the robotics team, essentially.
Okay.
And then with the feed-all system, it now, because we have these feeders and hoppers that vibrate in certain frequencies, depending on the part and the weight of the part, the shape of the part. Some parts might actually need a whole separate detangling system. So think again springs that actually combine. We might have this whole box that allows the springs to go into the box. They get thrown over all around the box, and then they come out separated. So some applications need a detangling system. So really, for the feeding system, for the feed-all system, we would need the parts to be sent to us. That's what we recommend.
Yeah.
We do a quick test with the feed-all and the vision system that we have. We call it the flex feeding system. We do a quick test to understand what's the right size of the feeding system, the right settings and parameters, and that's about it. And then we start the planning from there.
And I assume that process goes pretty quickly once you receive the parts.
Exactly. Yeah.
Yeah. So it's a very standardized process. That's so cool. Do you do that at more than one of your locations?
Yeah. So our main robotics lab is in Detroit. So we have all of these components in Detroit. The feed-all, the company that we're collaborating with, is out of Ohio, so very close to Detroit. So that would be the best spot to send parts, things like that. But we also have a demo system that we're showcasing in our main headquarters in Minneapolis. So feasibility, I would say, Detroit would be the best spot. But to view our demos and see what we have out there, both Detroit and Minneapolis.
Very exciting. Well, I think we're got about a minute left. Is there anything that we didn't touch on that you think everybody should really know about your work with robotics or SICK that we missed?
Yeah, no, just maybe to summarize what we said, right? So SICK is a sensor manufacturing company. We do sell sensors, but more recently, we're starting to do turnkey solutions, mainly in PAL, DPAL space and in flexible feeding, picking type of applications. The main highlights being extremely easy to use, quick turnaround time, and customizability for your needs and application.
And probably also for the workforce shortage and younger operators and stuff like that. You guys are designing the user interface to be really easy.
Exactly. You don't need a high-end robotics or vision knowledge or understanding of or background to set these systems up. They're meant to be plug and play, very easy to navigate and set up.
All right, very cool. Well, if you guys are, if you haven't seen these, if you've thought of SICK as a sensor vision company, they obviously still are, but now come check out these robotic applications. And I'm assuming that you guys may be adding more functionality in the future, kind of taking what is most popular, most in demand by your customers, and then finding more things to standardize.
Absolutely, more applications. So we're doing PAL, DPAL now. Maybe down the line, order commissioning is another one we might start providing turnkey solutions for. So yeah, let's see.
All right. Well, if you're here at the show, try to find SICK. And if you're not, we'll have some follow-up content, and you guys can visit them in Detroit or Minneapolis to see these systems in person. Thanks, everybody. See you soon on Automate Live.
Well, one of the things that really interested me the first time I came and visited you over there in the Akamai building in Boston was, and maybe this goes back to the decision to remove Boston Dynamics from the beginning of the name, is that the company is relatively, or maybe entirely, hardware agnostic, right? I mean, you were buying a lot of spot robots, but you've also been buying different humanoids to test out.
We have about 50 robots here. Some of them are arms mounted to the table, like an industrial arm, which we bought from Universal Robot. We have a couple of Unitree humanoids here, both the big one and the little one. We also have a lot of spot robots from Boston Dynamics. I think we have maybe 20 of them here. We have some Anybotics robots. We don't have a direct relationship with them other than being customer, but Marco Hutter, which is one of their founders, is the director of our Zurich office. And he's working, half-time with us and half-time with ETH, where he's been for a professor for a while. Yeah, we're hardware agnostic, and we build our own hardware. We have, a variety of hardware activities. You've probably seen the jumping bicycle, the parkour bicycle. We have arms and hands and torsos that we've been building, and we're building more stuff.
Yeah, you've been pretty open about this too, that, you were, I don't want to speak for you, but maybe to a certain extent you were hesitant to productize because you feel like productization can kind of, in a way, get in the way of innovation.
Hesitance too weak. We are not making any products. I think that we're really trying to work on the future, the next generation after the current generation. We want to make robots really smarter, more like easy to interact with, more like people. People know so much already that the task you're giving them is just kind of fits into the world that they know about. They have situational understanding, and that's really important, I think, for getting robots to be the next level beyond where they are now. Anybody who uses a robot today finds out pretty quickly what the limitations are, and that doesn't mean they're not useful, but it's a lot of work to make them do the things that they need, that you want them to do. So we're trying to, go past that. I think when you work on a product, there's lots of demands that you don't need to be working on if you're working on the future underlying technology, like the reliability of the robot. Boston Dynamics spends a lot of resources on making their, the spot robot out in the thousands of hours of time between failures or between interventions. And, we want to concentrate on getting the new thing just starting to work.
Yeah, I suspect maybe one of the biggest hurdles there, and I'm curious, what your thoughts are as far as the Electric Atlas humanoid, but is pricing, right? I mean, Boston Dynamics has been able to build these incredible robots for decades now, but in terms of actually being able to sell a humanoid robot, you kind of have to rethink it from scratch.
Well, it's true. At the Institute, we're not worrying about how much the hardware costs to build.
Yeah.
That's another specialized skill requiring a whole system of supply chain and understanding what volume you're going to make the thing at. And we're not doing any of that. We're making prototypes that can be very expensive, and that lets you, explore more quickly than if you're trying to design a product.
What was that initial conversation with Hyundai like when you were trying to get this together? What was the pitch like? We're going to spend all this money and not make any products.
I wrote up a short document that they reviewed, and
Hello, and welcome back to Automate Live. My name is Jana Martin. I'm the Media Production Manager at the Association for Advancing Automation, the host of Automate Show, and I'm joined this morning at the desk by Bob Little, the Engelberger Award winner this year. Bob, thank you so much for joining me.
Great to be here.
Well, Bob, there was just such a beautiful ceremony here last night at the show. Can you just talk a little bit about what it means for you to have won this award?
Well, I'm so proud, to take this prestigious award. Very few have won it over the decades, and I'm 40 years into the robotics. I've watched great leaders ahead of me that made life what it is today that we're living because of their leadership, who have won the award. And let's be honest, there's so many people who are deserving of the award that have not won it. So for me to be selected out of a very great cadre of individuals I feel are also deserving is a great honor, and I'm very thankful.
Well, you've dedicated your career to advancing automation and doing so many incredible things. When you first started nearly 4 decades ago, did you have any idea that we would be where we are today?
Yes, because when I grew up with robotics in the 80s as my career start, I thought they were such great technology that they could do anything.
Yeah.
I was on board with Joseph Engelberger when he talked about robots being capable of handling a variety of tasks. Um, and I was a young engineer, and I wanted to design and manufacture robotic components that were state of the art. I was successful in getting those components designed, but honestly, what I learned along my travels and journeys is that robots were not the perfect machine I thought they were. They were very fallible, and I was disappointed in that it was a lot of work to get robotic systems to do what they needed to do, and that is changing.
Now, why is that changing?
Over the years, the number one thing I think that robots had on their agenda in the 80s was becoming more reliable. So the 80s and the 90s was all about reliability. That was the focus, but they weren't flexible. And that is, robots had to be programmed for every task, and programming was slow and tedious.
Mm.
Then we got into, I would say, around the 2010s, and we started to see more focus on intelligence, and it started into the vision systems, where vision systems then became capable of handling and identifying a lot of different objects through pattern matching and machine learning. And that started to give robots more flexibility. Now, when we got into the chat GPT moment, um, only 3 years ago,
Yeah.
we've realized that we can create the intelligence behind the robots that can identify and make decisions, so that all this programming that we're doing from one object to the next is no longer needed, and robots then can perform much higher complex tasks.
It's such an exciting time to be in this world. But it took all of that work and to get here. Let's talk about some of like the fun moments along your career journey. One in particular, I want to ask you about a story you mentioned during your award ceremony speech last night. You mentioned that you, ATI, your company, had some equipment on the Mars rover. Can you tell us about that story?
Yes, a long time ago, I was running ATI. JPL came to us and said, "We are interested in a new force sensor to be used on the Mars rover Perseverance that will eventually launch and land on Mars and start doing experimentation." What people don't know about the Mars rover, there's a little robotics laboratory inside the machine. So when they dig for material in rock, that sample goes into a test tube. That test tube is handled by a little robot inside the rover, and then is stored. They need to make sure that that test tube was not going to be broken and was going to be handled with care. They needed force feedback. And so they came to ATI and they said, "We need your help. How do we create force feedback for the Mars rover?" They loved our technology and they said, "We want a contract with you for you to develop a force sensor for the rover." It was 7, 8 years of engineering it took to eventually complete that task.
Wow.
And to be honest with you, it was not for profit. We did not make money on that deal. We did it for the prestige. We did it for our country. We did it for science. And it was a very complex and difficult thing to do, but we learned from it.
Mm.
We learned how to make a better force torque sensor because of it. And then all the employees gathered around on launch day when the launch occurred, and we were all applauding. But then the big one was the landing on Mars, which occurred about 6 months later. and that one is very tricky because the amount of force on landing can be horrific. And success, it landed, and the force sensors started producing data, and you got another massive round of applause from our employees.
What a story. Now, I was going to ask you what you learned. What were the struggles about making this technology work going out of space?
Temperature. The Mars atmosphere was little of it. It gets really cold and really hot, and that temperature variability is massive. And force sensing can be sensitive to temperature, but these massive swings, we needed to keep accuracy on the sensor. And I remember having a conversation with the engineers, and they invented a new technology right in the middle of the project that would really help us with temperature compensation. And they said, JPL doesn't want to pay for the extra testing necessary for us to get this new temperature qualification done, because they say what we have is okay. And I said, you know what? If I'm putting a product on Mars, it's not okay to be just okay. I want the best product possible. So ATI paid for it, our own testing, instead of JPL, to get the new temperature compensation qualified.
Wow. Wow. What a journey. Congratulations on that.
Thank
That
you.
must have been so exciting. Let's just think back again to Joe Engelberger for just a moment. You actually did get to know him and meet him. What do you think he would think about where robotics is today?
Well, Joe would say, it's about time you got here. Because he was decades ahead in his thinking of what robots could accomplish. And he was what I would call a frustrated engineer. He saw the potential and was frustrated when that potential was not becoming headlines. And I think that if he was with us today, he'd be so pleased to see what we're doing and the accomplishments we would have. But he would tell you, this is what I expected. So I love Joseph Engelberger because I ran my own company, ATI, and I understood the frustration when we had a great product, but customers didn't recognize it. It took a lot of trust to build with those customers to finally get them to consider it. And that's what Joseph Engelberger had to go through.
What was he like? When was the first time that you met him?
I saw him at a trade show. I got to really know him better by watching his interviews because he was a very busy guy, and I never had a chance to really speak with him. So I paid attention when he had talks and speeches, and he wrote 2 books, which I purchased. He wrote one in 1980 and one in 1989, and it was very interesting to read one book in 1980 and see already the big differences between 89 and 1980. And I read those books, and I watched those interviews, and I really got to understand them better than just meeting him at the trade show.
That's so cool. And you're still so much like that. I mean, you're always on social media, you're always at all of these events. You're so diligent about you sit in the front row, you're very keen, you're very listening. Have you always been like a learner, a curious person?
I would say, when I was in high school, I didn't understand or grasp the discipline necessary to be good at your education. I wanted to have money for college, so I joined the military. And I asked for what is the most dangerous job I could do. They said at 82nd Airborne. I said, sign me up, and I became a paratrooper. That taught me discipline.
Mm.
And after that, I had the mindset that you actually have to go through a struggle to learn something. And so when I came out of the military and I went to college, I sat in the front row because I didn't want to miss one item. I was not shy about realizing I didn't know the answer, but I desperately wanted to learn it.
And you always have great questions too.
Yes.
I think that's an important part of learning, right?
you have to know enough to ask the right question. You have to be educated enough just to get educated.
What a good point. Well, let's just talk about like the industry kind of as a whole, since you are so plugged into what's going on. You write a lot about reshoring and rebuilding manufacturing. Are we actually in a manufacturing renaissance, or are we still early?
We are in a manufacturing renaissance. I personally have read as many articles and press releases as I could. I'm estimating I probably have read 1,000 articles and press releases concerning manufacturing, reshoring, and rebuilding. I've calculated my own personal numbers of $7.5 trillion of rebuilding and reshoring in the US of A over the last 2 years.
Wow.
These factories, the high majority of them are not built. They are in construction. So we have years of waiting for those facilities to get done before we can put robots in them. But some facilities have been completed, like TSMC's $35 billion semiconductor plant in Arizona was finished, I believe, late 24, early 25. And that's humming along right now. Now TSMC wants to build another 165 billion on top of that, and as well as an additional Intel and Samsung and Texas Instruments, and I can go on and on. The bottom line is this: a massive amount of semiconductor, pharmaceutical, mining, like rare earth mining and processing, agriculture, construction, and medical, and big is defense and aerospace, are all undergoing rebuilding and reshoring. It's because you can't see it doesn't mean it's not there. And a lot of people will come to me, they don't feel it yet.
Right.
But you will, because as these facilities are done, they're going to need to buy the equipment.
Okay, now what do you think is the biggest obstacle preventing more manufacturers from adopting automation today?
Big complaint is they don't have the workforce necessary for the new factory. So you're not going to build a new factory if you have two problems. One, you don't have the long-term customers, and two, you don't have the workforce to go with it. So the bottom line is workforce development is a priority. That workforce development, because we are getting more automated, has to be higher skilled. So we don't have a labor shortage, we have a talent shortage. There are workers out there who want to work, but they need to get trained. And so that is a very important aspect. And a lot is going on to help make that happen. In the meantime, as robots get smarter, robots then don't necessarily need as much manpower behind them. And that's important because we just don't have the manpower in order to do all this reshoring and rebuilding.
The buzzword of the moment is no doubt physical AI. When you see this happening, what reminds you of past robotics hype cycles, and what do you feel like is genuinely different with this?
Look, robots were a hype cycle back in the 60s and 70s, and people weren't buying into it. And so the bottom line is I've watched robotics was a hype cycle from decades ago, and look where we are today. Physical AI is not a hype cycle. It is a reality, but it's young and it's fragile and it makes mistakes. Be okay with that. We're going to get through that, and physical AI will become where we see robots were 40 years ago. We're at the beginning of that cycle now with physical AI.
Okay, last question. Do you think humanoids will become a major part of industrial automation, or will we end up with more different forms of robots?
Both. Humanoids will become an important aspect long term for manufacturing. I do not see the next few years humanoids doing a lot, but give it 3 to 5 years of development, and humanoids will be in factories making parts. But you will also see a cascade of different technologies that can make things work better. You're going to have both. And guess what? Because of all the reshoring, rebuilding, the market will absorb it.
Robert, we're so excited to see you at the next A3 event. No doubt you'll be there with all your great questions.
Absolutely.
Thank you so much for joining me today. And again, congratulations on the honor.
Thank you.
That's been it for Automate Live. Again, I'm Jana Martin, and thank you so much for watching.